Cancer is increasing throughout the world. We have 1,700 people a day dying. The argument is, there must be something wrong with those experiments. When it's said over and over and over again, it's mentioned in all textbooks, all biology, biochemistry, cell biology textbooks. The NIH is saying this. Every major hospital is saying this. How could it not be? So it's a denial. What we have here is no exercise, emotional stress, poor food, poor sleep, no friends, unhappiness, all of these things together. And now we are put ourselves at risk for all of these different problems, cancer being one of them.
Professor Thomas Seyfried, a world-renowned expert in cancer biology, genetics, and biochemistry, who's spent over 30 years challenging the conventional understanding of cancer. With nearly 2 million new cases diagnosed every year in the United States alone, it's clear the current approach to cancer is falling short. Globally, the numbers are staggering, and they're only expected to get worse. Why cancer has become so widespread in our society?
Clear evidence. Massively clear evidence. We have a diet and a lifestyle, and our technology has evolved so much faster than our biology, that cancer is caused by...
Hi, Professor Seyfried. I'm so excited to have you on the podcast. I am an admirer of your work and your book. And I want to first get into it by asking you this question, maybe a bit loaded, but can you give me your top beliefs on what or why cancer has become so widespread in our society?
Well, cancer is increasing. It seems like it's throughout the world, and of course in our society as well. But it's not one thing. We know about the oncogenic paradox. We solved that. That was a paradox put out by the Nobel laureate Albert Szent-Györgyi, who called the paradox, how is it possible that so many things have been recognized to be provocative towards cancer, and we can't figure out the common pathophysiological mechanism for this paradox? So we are accumulating in our society large numbers of toxins. We have a diet and lifestyle that's provocative to cancer. Cancer is what we refer to as cell division out of control or dysregulated cell growth, which can happen in any part of the body. So we have a diet and lifestyle that's extremely provocative for the development of cancer, coupled with toxins in the environment that work together with the diet and lifestyle, all contributing to this problem. And when you have what we have here is no exercise, emotional stress, poor food, poor sleep, no friends, unhappiness, all of these things together with foods that are poorly nutritious, full of highly processed carbohydrates, and you have an epidemic of cancer, diabetes, obesity, cardiovascular. It's not a mystery. This diet and lifestyle in our environment today deviates so much from how we evolved as a species hundreds of thousands of years ago. So as I tell many folks, we are a Paleolithic man living in a modern environment, and our technology has evolved so much faster than our biology. And now we are put ourselves at risk for all of these different problems, cancer being one of them. So it's not one thing. It's a whole constellation of things all impacting us together at this time and place.
So what is cancer of the metabolism? So when you're speaking right now, I'm guessing that you are separating genetics from sporadic cancer, correct? Because genetic cancer, I don't know, leukemia, these things that sometimes you think, but how did a child get cancer?
Well, you have to separate what we call germline cancer from somatic. There's two kinds of mutations that you see in cancer. They're called germline mutations, like BRCA1, P53, Li-Fraumeni, there's a retinoblastoma. There's a lot of these. They're genetic risk factors. And then we have what we call somatic mutations. These are mutations that you find in cancer cells. You didn't inherit these. They were acquired from being alive and cells dividing and this kind of thing.
Such as lung cancer.
Well, any cancer, you got to separate out the germline those that are inherited through the family, passed on from one generation to the next, like the P53 mutation, which affects mitochondrial function, cytochrome C oxidase 2, thereby reducing the efficiency of energy metabolism in the mitochondria of those folks, leading to a tumor in the brain or ovary or someplace like this. But it's not 100% penetrant, so we need to know about genetics. We need to know about penetrance. If like, for example, Huntington's disease is a neurological disorder caused by a mutation in the gene called Huntingtin. Anyone who inherits that mutation in that gene will develop the neurological problem, 100%.
That's chromosome 4, right?
Yeah, it's a chromosome 4, but it's 100% penetrant.
Yeah.
All right? But in cancer, we have no gene that's known to be 100% penetrant. So some people, the highest penetrance we have is the Li-Fraumeni P53, which is about 88% penetrant, meaning that 12% of the people, about 12%, would carry that mutation their whole life and never present with a tumor. So that means there would be a high risk factor. Many other cancer, like BRCA1, BRCA2, these breast cancer mutations, about 50% of women would develop a tumor from carrying that gene, but 50% won't. So it's a risk factor. It's not 100% penetrant, meaning it's not a fait accompli that you're going to get the disease with that. Those are germline cancers, okay? So you hear about Angelina Jolie having her breasts and ovaries removed as a prophylactic because family carries the gene. But there's diet and lifestyle issues that you could do to also significantly reduce your risk, even though you might carry the gene. But if you look at most cancers, just take the tissue out of the person's body, whether it's a brain tumor, a colon tumor, breast tumor, lung tumor, bladder tumor, melanoma, you see tens of thousands, millions of mutations in the nuclei of these cancers. And the National Cancer Institute calls cancer a genetic disease caused by these somatic mutations. That's why people call cancer as a genetic disease, because you do find mutations in these cancers. What we and others have shown is that they're largely irrelevant for the most part. They come as downstream effects of damage to the ability of the cell to generate energy through using oxygen. And they're an effect of the reactive oxygen species coming from damage to the energy organelle that generates energy, called the mitochondria. So yes, you do find all these mutations in cancer cells, but as I said, most of them are largely irrelevant they come as an effect, not as a cause. They don't cause. So this is where we differ between the National Cancer Institute, which says on their website that cancer is caused by genetic mutations, by mutations in the genomic DNA of the nucleus. This is the somatic mutation theory.
Yes.
And we clearly say that it's absolutely impossible for that to happen, because we have found driver genes in normal cells that never develop cancer, and we have some cancers that have no somatic mutations. And we did the nuclear transfer experiments. We looked at the data from those experiments, and they clearly show that a nucleus full of cancer mutations placed into a new cytoplasm, a normal cytoplasm with normal mitochondria, does not form dysregulated cell growth. So clearly the cytoplasm suppresses whatever the mutations might be in the nucleus. So we have clear evidence, massively clear evidence, that cancer is not a genetic disease. It's a metabolic disorder, because all cancers suffer a very similar problem. They're all dependent on fermentation for energy, not oxidative phosphorylation. So, I mean, we can break that all down.
Yeah.
But the issue is the misinformation, the misunderstanding in the country and the world today is that cancer is a genetic disease. Nothing can be further from the truth. They either do not look at the data or they don't understand the massive evidence to say that cannot be the case.
How is it possible for such a large conglomerate to, A, not look at the data, and B, not understand it?
Confirmation bias and dogma.
Okay.
Ideological dogma. I'm
Yeah.
telling. How is it possible that someone of one religion, a devout member of a religion, could all of a sudden drop it and immediately embrace another religion? It doesn't happen. Somebody would rather die than do this. If you're of one political, if you're a Republican and a dyed-in-the-wool Republican, you're not going to vote Democrat, and vice versa. Even though you might have the greatest candidate, the greatest platform that would support your very life, you will not change. This is called dogma. And then you have confirmation bias, is a situation where everybody's when it's said over and over and over again, it's mentioned in all textbooks that cancer is a genetic disease. All biology, biochemistry, cell biology textbooks. The NIH is saying this. Every major hospital is saying this. Everybody says it's a genetic disease. How could it not be? And then you read the literatures that absolutely say that this cannot be. What the argument is, there must be something wrong with those experiments. So it's a denial.
Yeah.
It's absolutely a denial. But I think the young folks come along who have not been indoctrinated into the genetic theory, and they start looking at it with fresh eyes and say, oh my God, how can anyone with any degree of cognitive capability think this could be a genetic disease when there's so much evidence to say it can't be? So that's the conundrum right now. And it's very hard to get somebody to accept a new idea when their salary depends on them not accepting it. There's a lot of factors that prevent them from wanting to make this change.
Well, I'm excited for you to teach us a new paradigm, one that hopefully we're all going to shift. I think in order to have a well-constructed conversation, we need to understand what the metabolism is, and we can start with the mitochondria.
Well, the mitochondria are an organelle inside the cell. We have a cell, just like we have organs in our body, the liver, the kidneys, the spleen. These are organs in our body. We have different organelles, structures inside a cell. The nucleus, everybody's familiar with the nucleus, contains the genetic material. And then we have the Golgi, and then we have the ribosomes, and we have the lysosomes. But we also have another organelle called the mitochondrion. And this is kind of a spaghetti network. There's a lot, they fuse and they fizz. It's a second organism inside one organism. This came about 2 billion years ago when two organisms fused together. One organism able to use oxygen and the other organism not able to use oxygen. So what happens then is these two organisms fused, allowed a division of energy labor, leading to multicellular organisms, metazoans, which we are the eventual descendants of these multicellular processes. This all came about as having an organelle that could capture oxygen and use it as an acceptor of electrons, thereby producing energy so much more efficiently with minimal fuel. Before that happened, all the cells on the planet, the living organisms, were mostly single-cell organisms that would divide rapidly, uncontrolled division, unbridled proliferation. And this would stop once the fermentable fuels, that was be fuels to be used without oxygen. Because originally our Earth had no oxygen. Don't forget, it was a very hypoxic environment. There was no oxygen. Oxygen was created by these bacteria that produced oxygen. Mm-hmm. So that little organelle became the mitochondrion. So the mitochondria is in all the cells of our body. When fertilization happens, the egg has the mitochondria. And as the organism develops, the mitochondria becomes semi-differentiated into the different organs and systems, but basically they're responsible for producing the highly energy efficiency. That's why you and I are breathing right now. We're taking in oxygen so I can know what I'm saying and say something and look at you. You can look at me, and we don't have to worry about our intestines. We don't have to worry about our lungs. All this is working because they're highly energy efficient. And that's driven by these little organelles called the mitochondria. And when cells divide, they have their own division cycle, by the way, but they pretty much control. They control the differentiated quiescent state of our cells, and when our cells need to grow to replace dead and dying cells due to wear and tear, they are very regulatory to allow our cells to replace those that have died or we need new cells in a very ordered way. So they control the destiny of all of our cells. So when that organelle becomes corrupted and can no longer do that efficiently, these cells fall back on the ancient fermentation pathways, which is unbridled proliferation. So the default state, which is what happens when you no longer have this control, is rapid proliferation. It's exactly what cancer cells are doing. They're falling back on these ancient fermentation pathways because the organelle that controls their destiny and their growth and their quiescent is become corrupted. And therefore, these cells fall back. And then when they fall back on this proliferation, you can't live without energy, ATP. So how do they get ATP? Well, they get it through non-oxidative procedures called fermentation. And then what we found in others, what are the fuels that drive fermentation? And that becomes the sugar glucose and the amino acid glutamine. We just published a big paper, it just came out in Twitter yesterday, showing how cancer cells in brain tumors, brain cancer cells are driven by two prime fuels, glucose and glutamine. And I don't, there's another fermentation mechanism that happens inside the mitochondria. That's why the paper is so big, because we've defined a second fermentation pathway inside the organelle that's supposed to respire. It's unbelievable. I'm sorry I have to be...
No, this is brilliant. This is so interesting to me. So basically what you're saying is the breakdown of the mitochondria is the reason for this, the dysregulation and dysfunction of the mitochondria.
Yeah. And it's also the reason for the collection of mutations in the nucleus that everybody thinks are important. So when the mitochondria become corrupted over time, it doesn't happen overnight. If it happens quickly, the cell dies and never becomes a cancer. That's what Warburg said. And we found...
I was going to ask you about Otto Warburg.
Yeah, well, I'll get to him in a minute.
We'll get there.
But when you have this dysfunctional mitochondria, it produces reactive oxygen species, radicals. They damage DNA, RNA, and protein. So most of the genetic damage that you see in the nucleus, the mutations that everybody is focusing on, not everybody, but majority of the cancer people are focusing on those mutations, they're caused by the abnormal radicals coming out of the damaged mitochondria, because those radicals are carcinogenic and mutagenic. They cause the mutations that people are studying. So the majority of people in the cancer field are studying things that are downstream epiphenomena. They're not they're an effect. They're not the cause. Now, because of that, that's why the cancer epidemic is continuing to go, because we have 1,700 people a day dying in this country every day from cancer. That's 70 an hour, 600, almost 12,000 per year, at least in 2024. And that's because we're not focusing on the really important issue of what's causing these cells to grow dysregulated, and how do you stop this? Very easy to stop them. You just pull the plug on their fermentation fuels. But you won't do that if you've been indoctrinated to think that cancer is a genetic disease.
Oh, I think there's also an education and public health issue here. Public health, yes, we've just established that. But how many people understand really? You know, I talk to people on a daily basis. The average person doesn't really understand what the mitochondria is, or phosphorylation and the fermentation process. So when you say pull the plug, what does that actually mean?
Well, it's not only the guy on the street, it's the guy in the top medical schools as well.
Absolutely.
Okay? Yeah, so you're not just talking about the guy on the street. You know, he has an excuse. He has an excuse not to know. But the guys in the top pharmaceutical companies, medical schools, and the NIH should know. And that's the dogma. That's what I'm saying. You can't blame some guy who's never been trained to know what this is, but you certainly can blame somebody that should know and refuses not to know. That's the problem right there. So anyway, that's why we have this tragedy, and it's a refusal on the part of the academic, because of the dogma, and it's because of the consensus bias. That's what it is, and because of the amount of money generated from current cancer therapies is enormous. You know, everybody's backslapping and having a good time. Well, we got 1,700 people a day dying from this disease, miserably too.
I guess what I'd love to understand is, how are we damaging the mitochondria through lifestyle habits? And we can separate them. We can first start with nutrition. That might be the easiest one to start with.
Well, I don't know if that's the easiest one to start with, because it's very vague and it's not clear. I mean, like, what do you say? How does nutrition damage oxidative phosphorylation, right? What is that?
Exactly.
Okay. So as I said, when we look at the oncogenic paradox, let's look at what that means. Carcinogens. Okay, we call about chemicals called carcinogens. They're called, and people know about. That item is a carcinogen. Stay away from. Why? Because it's going to cause cancer. How does it cause cancer? It gets into the mitochondria and disrupts oxidative phosphorylation gradually. Okay, you put that carcinogen in with a poor diet and lifestyle, and the probability of getting a tumor might be increased. Okay, what does it mean? So nutrition. Nutrition is a vague background facilitator of some of the more recognized provocative agents, like chronic inflammation. Okay, what is chronic inflammation? Okay, measure people's C-reactive protein in the bloodstream. That's kind of a marker of inflammation. You find a lot of folks that are overweight, obesity, type 2 diabetes, they have elevated C-reactive protein. That tells us they're already in an inflamed state. That inflammation with bad nutrition and no exercise puts the mitochondria in some cell in some tissue at risk for damage to oxidative phosphorylation. Radiation, for crying out loud. People fear radiation. Why? Because it's going to cause cancer. Unless, of course, you have cancer, then they nuke you with the radiation. That doesn't make any sense, right? Sometimes it does work, and I don't want to throw everything under the bus because a lot of the things in the standard of care can be effective. The problem is a lot of folks don't even know how to use those the correct way. They'll either kill their patients or they'll put people the ones that do survive are at risk for all kinds of damage to mitochondria in some population of cells. Intermittent hypoxia, another provocative agent, like sleep apnea and these kinds of things. They put intermittent hypoxia pressure on the mitochondria, causing them to fall back in a fermentation metabolism over time. And you put that together with poor nutrition, poor exercise, and poor the rest of this, and you put populations and cells at risk. What else? Age. Older you get, you're more likely to damage oxidative phosphorylation. What about oncogenic viruses? Wow, you got to love those. Papillomavirus, hepatitis C viruses. How do they cause cancer? They actually get into the mitochondria, disrupt oxidative phosphorylation. You're in a poorly nutritious state. You're poorly processed carbs and all this stuff, and you put your body in inflammation. You put all these things together, come and pound out and reduce the energy efficiency in a particular population of cells, in a particular organ, thereby leading to either breast cancer, colon cancer, bladder cancer, and you can go up and down the list and find them: ovarian cancer, uterine cancer, lung cancer. We've always said smoking causes lung cancer. Okay. So one of the greatest reductions in cancer is the anti-smoking campaigns from the 1990s. Okay, and the American Cancer Society loves this. They say, "Oh, look we've dropped cancer death rates by 33%." Wow, why? Because people stopped smoking. Is there any new therapy that's come along to drop? No. It's all prevention. Prevention was the biggest effect on reducing cancer death rates. So no new drugs or any of this kind of stuff. People are living. We have a lot of what we call millions of cancer survivors, thereby the grace of God surviving the toxic poisons and all the stuff they give you, mutilations and everything. But those folks are mostly damaged in some way, not all of them. But the cancer survivors often die earlier because they've been brutalized by a medieval system.
Yeah.
And they never feel out of the woods. They have depression, neuropsychiatric. They have all kinds of other maladies because they've been nuked and poisoned, basically, to make them healthy and survive. Right? I hate to say this kind of stuff, but this is basically what it is. I mean, you can't sugarcoat this stuff too much.
Yeah, no, I completely agree with you. I've been going down this entire, I think in the last 3 weeks, everything just keeps pointing back to metabolic health and also insulin. I don't know if what your take is on insulin as a driver of metabolic dysfunction.
Well, I mean, why is insulin up? Because you're no longer insulin. Your glucose, your body is no longer responding to elevated glucose, so you have insulin insensitivity. And most of this, folks, this is type 2 diabetes, insulin sensitive. I want to separate type 2 from type 1 for sure. They're not the same. But obesity, type 2 diabetes, insulin insensitivity, systemic inflammation. I mean, it's all together in the same pot. But when you do metabolic therapy, interestingly enough, you start restricting the fermentation fuels for cancer, which I'll discuss, glucose and glutamine. But you also reduce inflammation. You reduce systemic inflammation. You increase elevation of ketone bodies, which are really super fuels that really enhance the health and vitality of mitochondria. So, but nobody wants, not nobody. It's hard for our members of our society, myself included, to get into nutritional ketosis. I got to go back and live
It's
like
so
I was,
hard.
like I was some Paleolithic guy, hunter gatherer. And when you have, donut shops on every corner and delicatessens, it becomes very hard to live like the Paleolithic man.
Yeah.
And who does? Who wants to live like that anyway? But you roll the dice, you take the risk.
Can you talk to me about the discovery of glucose fermentation? Because I really want to understand that, and I also want to talk about Otto Warburg and his findings.
Yeah, well, Warburg was the first to identify the origin of cancer. It's a long story. Basically, he was thrown under the bus when everybody thought cancer became a genetic disease, or really thought it was to be mutations. So that Warburg was left behind. But he actually knew what was causing cancer. We have cleared up a number of the mistakes that Warburg made. So we've kind of dusted off and polished off his original hypothesis and developed his original hypothesis now into a theory, the mitochondrial metabolic theory of cancer.
Yes.
But he originally saw that all major cancers had lower oxygen consumption and kept throwing out lactic acid. And lactic acid is the waste product of glucose fermentation. It's called lactic acid fermentation. So, and he argued that the reason why cancer cells did this is because their mitochondria were in some way defective or damaged. We now refer to it as oxphos insufficiency, which is what ultimately it comes down to. But what was interesting about cancer is it continued to ferment glucose or lactic acid fermentation. Lactate is the waste product of glucose fermentation, and which appears then outside the cell and in the bloodstream and things like this. It does that even in 100% oxygen. So why would a cancer cell continue to ferment glucose in 100% oxygen? He reasoned had to do something with the mitochondria. So his findings were based on biochemistry readouts. He never looked they didn't have the electron microscope back in those days. So he never was able to look at mitochondria. But I did, and my colleagues did, and a number of people have. And every major cancer we look at under the electron microscope, we see abnormalities in the structure of that organelle. The very intricate structure of the organelle is abnormal. And in evolutionary biology, structure determines function. If the structure of the organelle is abnormal, the function of the organelle will be abnormal. And Warburg said they were abnormal. They were not taking in as much oxygen, and they were continuing to ferment glucose, which should not happen in 100% oxygen. It only happens when you have hypoxia, and there was no hypoxia. So why are these tumor cells continuing to ferment? They had to ferment to stay alive because oxidative phosphorylation was inefficient. So now let me give you an example. We will all do that under certain conditions. One of the conditions is if we hold our breath long enough, our body will fill up with lactic acid. If you have a heart attack where the heart stops beating, we fall down and our bodies immediately start filling up with lactic acid. You turn purple, and what you notice in the bloodstream is an immediate rise of lactic acid and another acid called succinic acid, which is what alerted us to the fermentation of glutamine. It's not just glucose. We discovered now, and that's our big finding here, is that there's an amino acid that's actively fermented along with glucose. These two fuels are being fermented. And the waste product is lactic acid from glucose and succinic acid from glutamine. So when people have heart attacks, their bloodstream fills up with succinic acid and lactic acid. As soon as they start breathing, the lactic acid and succinic acid go away, okay? Because now we're replacing fermentation back with oxidative phosphorylation. The cancer cell continues to make lactic acid and succinic acid even in the presence of oxygen. That tells us no uncertainty that these cancer cells are being driven by a fermentation metabolism, and that because oxidative phosphorylation is defective. And how do you know that? Because you look under the electron microscope and you see the cells are damaged. And the other thing they do is they accumulate lipid drops in the cytoplasm. That's another marker, because normal cells that have normal mitochondrial function will burn lipids and ketone bodies for energy, because they can use oxygen and get energy from fatty acids and ketone bodies. Tumor cells can't do that because their mitochondria defective. They collect lipid droplets in the cytoplasm, and they store them there, because if they try to use them, it'll kill the cell. So they store them as a protective mechanism. So clearly, when we look at cancer cells, whether it's in the body, whether it's in the culture dish or wherever, the cells are screaming at us biochemically and morphologically, telling us in no uncertain terms why they are growing out of control. So you just have to be able to look at the signs and understand what the cells are telling you and make a decision that, wow, these cells can't grow without fermentation. How do you kill them? Take away the fermentation fuels. Just starve them of glucose and glutamine.
So glutamine, you were the first one that actually brought this to light. It's interesting, and I want to go into what glutamine is as an amino acid and how that's one of the drivers, along with glucose.
Yeah, well, glutamine, with the cancer field knows, they call it glutamine addiction. They knew cancer cells used a lot of glutamine, but they thought the glutamine was respired. It's called anaplerosis, where glutamine comes into the tricarboxylic acid cycle, the Krebs cycle, if you want to do it, and is fully oxidized in the Krebs cycle. What we found is, no, that's not the case. Glutamine is metabolized it goes through part of the cycle and dumped out as succinic acid. So in order to grow, glutamine is the most abundant amino acid in our body. If you look at the serum concentration of amino acids, I mean, glutamine is like half a millimolar, 500 micromole. It's very high. It's super high. Why is glutamine so high in our bloodstream among all the 20 amino acids that we know are in biological systems? Why is the glutamine so high? Well, that's an important amino acid, because if we are burned and we have bacteria from the outside world getting into our body, our immune system, macrophages and leukocytes, use the glutamine powerfully to kill the bacteria that enter our body. So our very immune system needs the glutamine. It's very dependent on glutamine. Our urea cycle needs glutamine. Our gut cells need glutamine. So glutamine is it's considered a non-essential amino acid because we can make it from glucose. But it's really, for cancer, it's an absolute essential amino acid. And the other thing is, we've shown, no uncertain terms and very clear, that all metastatic cancers, regardless of where they come from, are a type of immune cell called the macrophage. So we know what the metastatic invasive cancer cell, it's part of our own immune system. So once you know that, and you know what they eat and survive on, now you know how to kill them. The problem is, what I'm saying to you,
is that through natural killer cell activity?
Yes. Well, natural killer cells are part of the kinds of cells. They're kind of a mesenchymal. They're in the macrophage, leukocyte, that group of cells. Any one of which could have a damaged oxidative phosphorylation and then turn into a metastatic cell. Sometimes fusion hybridization. We published all these papers on this whole thing. But the field, unfortunately, keeps chasing things related to genetic mutations, failing to see the very obvious things that the cancer cells are telling us, because they're all focused on downstream epiphenomena. So even though I publish these papers, I clearly show what's going on. I clearly show how we can manage cancer very, very effectively without toxicity. It's ignored because the field is so hell-bent on thinking this is a damn genetic disease when it's not. So people say, well, how come nobody knows what you're talking about? And for the life of me, it has to be some dogmatic thing. Because anybody with a few functional brain cells can look at the information and say, what the hell is going on here? How come nobody knows about this?
Could your theories stand then if, let's just say, somebody was diagnosed with stage 1 cancer? It's not metastatic yet. Stage 1, found a tumor. How do you challenge the conventional cancer treatment for that?
Okay, so what we do in a situation like that, and we have some big papers coming out, my Press Pulse paper, what I did with some physician friends of mine, and we have a really big one coming out any day now on managing glioblastoma. But it could also be it also could be used for almost all cancers. We just put for GBM because nobody has anything. We haven't made an advance in glioblastoma 100 years, so there's no advance in that field. We're gonna make a huge advance in that once they come to realize that it's a metabolic disease. But what was your question?
I wanted to know how you manage the conventional cancer treatments if you've been diagnosed with stage 1.
Yeah, stage 1. Okay, so normally it would be diagnosed as a lump. Some indication that there would be something going on. Person goes to the physician, they do something. I don't know, they have a lesion or something like this. Okay, good. We're going to use non-invasive PET scan, MRI, CAT scan, something that could identify where this is, maybe, and get an idea from an outside look at this. The last thing we want to do is stick it. We don't want to take a biopsy of it because you could potentially spread it. And there's dozens of papers in the scientific literature showing that biopsies can spread cancer. So we don't want to do that. Not in everybody, but 1 out of 500 people. Why would you put them at risk for metastatic cancer and potential a life-threatening illness just because you want to look at some mutation and things that are largely irrelevant? So you just assume, okay, if it's a benign tumor, what we do is we get a full blood work. I don't do this. I'm not a physician, but my friends do. We get full comprehensive blood work, and then we bring the glucose ketone index, the ratio of glucose to ketone bodies in the blood using the glucose meter, ketone meter, and bring it down, and then start looking at this tumor. Go back and see if it changes. It's either not going to get smaller. Most of the time, it gets smaller. Now, if you shrink it down, don't forget what you're doing is you're shrinking down any inflammation, edema, anything associated with the microenvironment of that tumor. And if you look at the imaging now, you see changes because this person has gone through a restricted diet that it doesn't have to be keto. It can be any diet that brings your GKI, glucose ketone index, to 2.0 or below. And you do that for 10 or 14 days. And then you say, oh, my God, this tumor's changed. Now, the surgeon or the oncologist has the option to go in and take it out completely. Just do a lumpectomy or a surgical procedure because now the tumor is circumscribed. Now it's shrunken down. The inflammation is reduced. Edema is reduced. Anything that would look pathological is significantly reduced. Then your probability of long-term survival or possible cure is greatly enhanced. Now, if the person has a stage 4 tumor where you already have metastatic lesions outside the area where it's supposed to be, then we have to be aggressive. What we do is we do the same kind of a thing, and now we bring in glutamine targeting drugs that will now go after the glutamine. So you bring the blood sugar down, get the low glucose ketone index down real low. Good. We're shutting off the glucose availability to this tumor. And now we're going to come in with these strategic drugs, mostly repurposed drugs, right? They don't cost much money. And then you're going to start hammering the glutamine availability with the glucose availability at the same time, transitioning the entire body over to ketones and fatty acids, which are burned by our normal cells. Cells that have normal mitochondria can burn the ketones and the fatty acids where the tumor cells can't. So the tumor cells are now put at a competitive disadvantage, and you bring down the inflammation, and then you monitor again non-invasively. You begin to monitor those PET spots that you see on PET scan. They start to disappear. Where did they go? What happened? All of these lesions start to disappear. Now, and sometimes all lesions disappear, maybe except for one. And then you can go in and surgically remove that. On the other hand, like we have seen, some of those lesions never go away. They just sit there in a kind of a dormant, indolent state. Then you have to consider options as you go forward. Like we had a brain cancer guy with a glioblastoma that it never went away. It just grew so indolent. He lived 10 years with his glioblastoma, but he died from a hemorrhage from a small surgical debulking procedure. But the tumor never killed him. So, but he lived with it. He lived 10 years. He had 2 kids. He got married and all this. If he did standard of care with radiation and chemo up front, they said he was going to live 9 months or 12 months at the most. He lived 10 years because he avoided the radiation and all that other stuff. So he also had an IDH1 mutation, which gave him a benefit. But that beside the point. But we're seeing more and more people live longer with a higher quality of life. Does any of this cure anybody? I don't know. All I know is I get emails back from people that should be dead, they're still alive. But it could come back at any time and kill them. I don't know. But the issue here is we're seeing longer survival with a higher quality of life. Whether any of it leads to a cure, everybody wants a cure. Be happy you're living longer and a higher quality of life,
Correct.
And who knows, if you die at 98 years old from a heart attack when you had cancer at 35, then we can say this guy was cured. But we don't know. And we just know that we have a much better chance of putting cancer in a less aggressive, more indolent state. Whether you get a cure or not, we don't know. But you certainly feel a hell of a lot better. Your energy is back. Your overall life is improved. But whether it's cure or not, I don't know. So this is where the future is going to be. The future will be metabolic therapy for cancer. And we can bring in...
That's kind of like precision medicine. That's kind of like what's happening now, but it's only reserved for high-income earners, really.
Well, that precision medicine is brutally imprecise. That's why we have hyperprogressive disease with these immunotherapies. So,
such as?
Hyperprogressive disease is where the therapy kills you faster than the disease does. It's a term, hyperprogressive disease, right? So when it's so precise, let's look at the precision. Wow, we have a marker on a tumor cell, and we're going to use this immunotherapy just to kill those tumor cells. And sometimes you do. Sometimes it works. About 20% of the time, you do pretty well. But sometimes they have those same markers on your liver and kidney. So you blow out your liver and kidney while you're trying to, okay, we got rid of your tumor, but we also blew out your liver and kidney, and now you die from kidney and liver failure. So how precise is that? Right? So, I mean, they're doing some crazy things. You have no idea the crazy stuff they're doing in the oncology centers. They're trying to make vaccines against mutations on some of these tumor cells when the same mutations exist in normal cells. Can you believe this? I mean, I can't believe how little the guys that are in the top medical schools know about cancer. It's scary. It's actually scary when you think about it. So, and the poor guy on the street has no clue. He runs into these places thinking these guys know what they're talking about. And many times they do. I don't want to make it look like none of these guys know what they're doing. But we got 1,700 people a day dying, 70 an hour. So somebody doesn't know what the hell they're doing. So, and this shouldn't be. These deaths should not be happening like this. This is nuts.
Let's talk about, because I know you're a proponent of the ketogenic diet, which you've just mentioned as a promising anti-aging interventions, but why don't we talk about diet and lifestyle strategies? I really do want to get into exercise as well and how that plays a role.
Well, diet and lifestyle, listen, when I first started doing all this stuff many, many, many years ago, we were doing calorie restriction. And we knew that which turns out to be water-only fasting. So we were seeing really spectacular effects in mice by water-only fasting. But then we said, oh, man, who's going to want to do this? They're going to think you're a nut going out there. How am I going to manage? Oh, don't eat anything for 30 days. Well, who the... Well,
who's going to do that?
Right? I mean, this guy's crazy. So we said, what can we do to this? I worked in the epilepsy clinics with the epilepsy at Yale University for 9 years down there. So we were working on ketogenic diets and this kind of thing for a long time. And we knew I started the ketogenic diet workshops because in the field of epilepsy, ketogenic diets are acceptable as a way to manage seizures in little kids. So, and it became acceptable in that part of neurology, neurological problems. But for cancer, we didn't want to say go starve yourself. So we said, why don't we do a ketogenic diet? It's just reducing blood sugar and elevating ketones in a more natural way. So then all of a sudden the diet crazies got involved with this. Oh, you got to do this. What can I eat? So then we developed the glucose ketone index calculator, which we developed here at Boston College, which lowers the blood sugar and elevates the ketones, regardless of what the hell you want to eat. You want to be a vegan? Go ahead, be a vegan. You want to be a carnivore? Be that. You want to be a Mediterranean, pescatarian? I don't care what you want to be. Just get your GKI 1.0 below, and you're going to start putting metabolic pressure on this. So on these cancer cells. So people always ask me, well, he didn't say what I should. I don't give a damn what you can eat. Just bring your GKI down. And you say, well, I tried and it didn't go down. Well, why don't you try something else and see if you can get it down? And if it doesn't go down, do water-only fasting. It'll definitely go down.
Yeah.
And then add food back and find out what you can and cannot eat. Everybody is their own experiment in this particular case. There's no universal thing that works for everybody the same way. So you have to then experiment on your own body and say, okay, what do I need to do? Is it a keto diet, a Mediterranean diet, a pescatarian diet, carnivore diet? What is the best diet to get me into a low GKI, which is a low glucose ketone index? Then you're going to start putting the metabolic pressure on these tumor cells. Then you come in with the drugs that target glutamine. So yeah, now exercise is absolutely essential for the therapeutic efficacy of this process, because we found that exercise does two things. Number one, it lowers glutamine. That's great. Exercise itself will lower blood glutamine. Number two, when you're exercising, your muscles are taking in glucose from the bloodstream and converting it into glycogen or burning it on the spot. So muscle and brain get most of the glucose in the body. The brain takes glucose but can switch to ketones, but will always take the glucose. Muscle, if you're exercising, the muscles are going to take in glucose. Who's the lowest guy on the totem pole to get the sacred glucose? It's a damn tumor cell. So once your body is in nutritional ketosis and you are exercising, those tumor cells are going to be under a world of hurt. And then you come in with the blast on the side with the glutamine targeting drugs, and you blast these things out, for the most part. And this is where the cutting edge is right now. How many different glutamine targeting drugs can we use? Some of these parasite medications, we have a paper out showing that they target glutamine too. So, and glucose simultaneously. It's a package of finding out what works best for each cancer patient to keep them in a high quality exercise state, very healthy, eating the right foods to keep a low GKI while they're slowly degrading their tumor. So, and often what we see is also the diabetes goes away. The obesity goes away.
Of course, yes.
All these other chronic problems go away along with the cancer. This was in our Press Pulse paper. We published this.
So let's, look, I'm telling you, after the last, I've heard the word ketogenic as it relates to psychiatric disorders, as it relates to obviously type 2 diabetes, metabolic dysfunction, now cancer. I know that I discuss it with Alzheimer's disease patients, which is my primary area of research. And so it's becoming more and more clear to me that this ketogenic lifestyle, albeit a hard one to get into, I bought the Keto Mojo testing strips. Very hard to get into. Oh, yeah. And let me tell you, I had an orange as an experiment, and that just pushed me straight out of nutritional ketosis.
Oh, yeah. Absolutely. Absolutely. Try a Coca-Cola. And see what that does. We did that. It's like hitting the bell in the circus. The thing goes up and rings the bell.
Exactly.
It's unbelievable.
Let's finish up by talking about invasive versus non-invasive tools for cancer detection, something that is very close to my heart. I lost my grandmother and auntie to pancreatic cancer, and the sad thing, I know many people who have, and the sad thing is it's like, oh, we found out, then 2 weeks later they were gone. And we had no signs of it prior to that, and that scares me too.
Yeah, well, when you have pancreatic cancer, it can get on you bad without you knowing it much. By the time you say, "Oh my God, what's my digestion?" and all this kind of stuff, it's spread out. And if it blows out your pancreas quick, then a lot of the digestive hormones and a lot of the things that insulin and all these kinds of things can be corrupted, and you can go into all kinds of metabolic dyshomeostasis. But what we do know about pancreatic cancer, like we know about all cancers, they can't live without glucose and glutamine. So you got to get on top of that glucose and glutamine as quickly as possible. You got to start bringing the GKI down as low as you can. And yes, it's going to be delicate. We have to use certain drugs and certain ways to target this because it is a fast-moving cancer. But if you can get on top of it, if you can get just a little bit on top of it, you can slow it down significantly. But by the time they give you, these terrible drugs, make your body weak, toxic drugs, and they sometimes do a Whipple procedure, or they try to do these surgical things to make, and a lot of times it doesn't work. You got to get on top of that real fast as soon as that diagnosis. And even then, I'm not sure. We have not yet had a person with. We have a lot of pancreatic cancer people doing metabolic therapy, and the outcomes. These guys are still alive, so I'm really not sure what's going on. But and I don't see patients. Believe me, I'm in a biology department. I don't see any of this. We have friends that are in the trenches that are looking at some of these folks. But to do a careful exam, you got to get those. You got to get on top of that glucose and glutamine right away, and be aggressive with it up front. But do it without harming the patient. There should be no nausea, vomiting, diarrhea. There shouldn't be any of that other than what would come from the tumor itself. And you have to bring that whole. You have to make this tumor less angry, more indolent. And then once you can do that, then you have much better options. And you have to use non-invasive imaging to do this. You don't want to go in there and cut and stab and do all this stuff. It's like it explodes the cancer cells throughout the body. And they're very aggressive. And we know what they are. They're macrophages. So we know what they eat. We know they're dependent on glucose and glutamine. We just have to get that onto them as quickly as possible.
So managing glucose, ketogenic state. One other thing I wanted to ask about as well is you mentioned emotional stress.
Yeah, that's a big one. People in our society are sitting in traffic. They're trying to commute a lot. Now, we have a lot of emotional stress in our society.
Divorces, deaths of family.
Yeah. Job problems in the job, anger. People are just pissed off about a lot of stuff. You try commuting 2 hours in Chicago, Los Angeles, New York City traffic. I mean, it's brutal on your body. With people cutting you off, you're angry. Then you get home, you got a bunch of kids yelling, they need food. You're trying to relax, and there's always something going on. This is very different from our Paleolithic lifestyle that we had for hundreds of thousands of years. Even during the Neolithic period, people were outside, they were walking, they weren't sitting in cars and traffic and exhaust fumes and sitting in front of a computer on a cell phone all day long. All these young kids are getting all freaked out by what somebody says on Instagram about them, or YouTube, whatever the hell they look at. They're getting all freaked out. They're in a bad diet. They're pounding down bad food, no exercise. And the next thing you know, they have neuropsychiatric problems, depression, cancer, type 2 diabetes. I mean, it just wears on you. Yeah. So, we have a thing here. The cancer, the way of cancer life, no exercise, no happiness or friends, poor food, emotional stress, and poor sleep. You put all that together, and you put yourself at risk for not only cancer, but a variety of other things. So get plenty of exercise, find friends that make you happy, enjoy your social interactions, make sure you eat food that has minimal levels of highly processed carbohydrates. Try to reduce stress. Exercise can help you reduce stress. There's a lot of ways, massage therapy, music therapy, a lot of things can reduce stress. And make sure you try to get good sleep. And I say, well, try. But you know how it is. You ever see these New Yorkers running around? Yeah, I go down there too.
Trust me, I'm right in the midst of it in the West Village. It's a crazy town over here.
Well, it's just not New York. It's Hong Kong. It's all the different places. Yeah. Everywhere in many big cities. People are running around. We're in a high diet and lifestyle stress environment with more and more chemical carcinogens and different kinds of things, all together, all impacting together, producing a wave of chronic diseases. That's what we call chronic diseases. It's not only the food and nutrition, it's the lifestyles and everything else that go together with this. And so it becomes a chronic, inflamed environment. And our Paleolithic ancestors, they had a lot of exercise. They had no processed foods, all these kinds of things. A lot of exercise. I don't know about their stress levels and things like this, but we know Aboriginal folks that when they were looked at for cancer, it was almost non-existent. So tribes of people who live according to traditional ways and lifestyles, cancer is an extremely low, very low frequency. So is diabetes and some of these
and Alzheimer's disease.
Yeah, Alzheimer's. Well, people always say, well, they didn't live long enough to get Alzheimer's. Listen, Alzheimer's is just I would say a good 50 to 60% of Alzheimer's is diet and lifestyle problems. You do have significant disease genes, the presenilin mutations and some of these things that make you really predisposed to that. But that represents what, 5 or 6%?
Correct.
And you have an epidemic of Alzheimer's coming down the pike here. So where's all that coming from? Diet and lifestyle, baby. That's where it's all at.
So tell me one last question. What's the future of cancer prevention and research for you?
The nice thing about metabolic therapy is metabolic therapy can both prevent cancer as well as treat cancer. You can, as long as you keep your mitochondria healthy by living in a kind of semi-ketotic state. We call it nutritional ketosis. You don't have to live there all the time, but it might be good to do intermittent fasting. You can prevent cancer with that strategy. Now, if you get cancer, you do just a little bit more aggressive strategy and bring in the glutamine targeting drugs. Now, this is very interesting between metabolic therapy and standards of care, right? I think people, I know a lot of, you got the GKI, the Keto Mojo meter. There's a lot of people who don't have cancer that are exercising and using the glucose ketone index to stay healthy. So they're doing it to keep their mitochondria healthy and preventing cancer, but they'll also prevent diabetes and a lot of other chronic diseases at the same time. So, but when you go to the cancer institutes, you don't see people lined up in front of the major cancer institute to get their prevention radiation and chemo. Give me a shot of radiation and a dose of this chemo to prevent me from getting some sort of cancer. It's absurd. You only do that after you get that's also absurd. What are you poisoning and irradiating people? You can manage that cancer strategically if you understand how to target those two fuels, and that's the future. So the future is both prevention and management using a very similar structure, a very similar approach, which is ketogenic. We call it ketogenic metabolic therapy, which will prevent cancer, and then we use it to manage cancer together with repurposed drugs. So that balances everything out. The only problem, there's two major problems. Number one, it ain't easy.
It takes a lot of time.
It takes a lot of willpower. And the other thing is right now we can't figure, nobody has yet figured out how to make money on this. Big money. So you want to be able to have a diet and lifestyle issue where you can replace revenue from some of these other failed procedures. So, which are very expensive, very costly, but they generate a lot of revenue for these different organizations. So until some entrepreneur comes along to figure out, okay, that's the beauty of us. There's always some guy that starts to figure out how to make money on a new technology, because this metabolic therapy is a disruptive technology for a system that's currently broken, but it can be morphed into something that's very exciting and profitable for a lot of people once they understand the concepts.
Well, Dr. Thomas Seyfried, thank you so much for coming on the Neuro Experience. You are very energetic and passionate about this. I'm so excited to show people your book. Where is it available? Everywhere?
Yeah, Cancer is a Metabolic Disease. It's interesting here. I only wrote one book. There's a couple of pirates out there saying that putting my name on summaries of my book, and I never wrote those things, right? Okay. So I only wrote this one here. The interesting thing about Cancer is a Metabolic Disease, I wrote this in 2012, and it's selling more now than it's ever sold ever. So
there you go.
There you go. So something's happening. And maybe somebody's finally learning what's going on here. And there's
public education that you're giving us.
Yeah, I guess, whatever it is. But it's a lot of fun because it works. And it has real benefits for a lot of folks.
Yeah. Well, I can't wait to share it with the world. Thank you so much for being part of this.
Oh, thank you very much for having me. Real pleasure. Thank you.